Welcome everyone to this video. Today we will understand the jet test, one of the most common and simplest hypothesis testing technique. By the end of this session, you will know what a jet test is, when to use it, and how to calculate it with an example. So without further delay, let's get understand. What is jet test? A jet test is a parametric test based on the standard normal distribution. The idea originated from Gauss work on normal distribution. Jet test basically check whether the sample you collected is significantly different from the population. It is used mostly for large sample size, where sample size is greater than 30 and when the population standard deviation is known. We used jet test. Assumptions of jet test include data follow a normal distribution, sample is randomly selected, population variance or standard deviation is known, and sample size is generally large, means greater than 30. Observations are independent. These assumptions ensure the jet test gives accurate result. If population standard deviation is unknown or sample is small, a t-test is preferred. Make sure your data meets these basic conditions before performing a jet test. When do we use a jet test? When comparing some sample mean with population mean, when testing difference between two independent means, when testing population proportion, when sample size is large, it means greater than 13, when population standard deviation is known, and it is also used for proportion testing. Types of jet test. Jet test is basically three types. First is one sample jet test, when we compare sample mean versus population mean. Second is two sample jet test, when we compare two population mean. And the third one is jet test for proportion, when we check proportion claims. These three forms help in different research scenarios. In business, HR, and social science studies, one sample and two sample jet tests are commonly used. There are three common types. The most used one in research is the one sample jet test, especially when testing if a sample mean differ from a known population mean. Jet test formula. The formula of jet test is Z equal to x bar minus nu upon standard deviation upon n in root, where x bar is equal to sample mean, nu is equal to population mean, standard deviation is equal to population standard deviation, and n is equal to sample size. The formula measures how many standard errors the sample mean is away from the population mean. Example 1, mean salary test. A company claims average salary of employee is equal to 50,000. It means the population mean is 50,000. A sample of 40 employee has mean is 52,000. It means sample mean is 52,000. The population standard deviation is 8,000. Sample size is 40 and the test at 5% significance. It means alpha is 0.05. If we are putting all these values in the jet test formula, then we get the result. We get jet is equal to 1.58. And the interpretation include critical Z is equal to 1.645, calculated Z is equal to 1.58, and the conclusion we fail to reject null hypothesis. इट मीन्स हमारा यहाँ पर जो क्रिटिकल जेड यानी कि जो क्रिटिकल जेड दे रखा है एट 5% लेवल ऑफ सिग्निफिकेंस पर, वो कितना गिवन है हमें 1.645, और हमने जो जेड कैलकुलेट किया था उसकी जो वैल्यू निकल कर आई थी वो आई थी 1.58. इट मीन्स जो क्रिटिकल जेड की वैल्यू है वो ज़्यादा है हमारी कैलकुलेटेड वैल्यू से. इट मीन्स जो यहाँ पर टेबल वैल्यू दे रखी है वो हमारी कैलकुलेटेड वैल्यू से ज़्यादा है, तो हम क्या करेंगे, एक्सेप्ट कर लेंगे नल हाइपोथेसिस को. अगर इसके अपोजिट रिलेशनशिप होता तो हम क्या करते, रिजेक्ट कर देते नल हाइपोथेसिस को. or null means there is no relationship. There it means there is not enough evidence to say the average salary is higher than 50,000. Standard normal distribution curve. A bell-shaped normal distribution curve where mean is 0 marked at center, z-score labeled at -1, -2, -3 and +1, +2, +3. Shaded right tail region showing rejection area. This curve is the heart of z-test. Z-scores show how far your sample mean is from the population mean. The shaded tails help viewers to understand rejection criteria visually. Z-test step-by-step procedure or flow. The first step is to set the null hypothesis. Assume no difference. Then set alpha. Usually alpha is 0.05. Then calculate Z using the formula which I have already discussed in previous slide. Then compare calculated Z with table value. And the last step is to make decision. Accept or reject the null hypothesis. Thank you for watching this video. If you found this video is helpful for you, then you can appreciate me by like, subscribe and share. Thank you so much.